Hello students, we are learning about module 3 of digital switching systems. Classification of switching networks. The classification of switching node is based on inlets and outlets. Single stage switching network, two stage switching network, three stage switching networks, and four stage switching networks. Single stage networks. Single stage switching network having m inlets and n outlets, consisting of a matrix of cross points. These may, for example, be separate relays or electronic devices or the contacts of a crossbar switch. The network could also be constructed by multiplying the banks of m uniselectors or one level of a group of m two motion selectors, each having n outlets. In future system may use photonic switches in which optoelectronics devices are used as crosspoint to make connections between optical fiber trunks. The figure shows electromechanical switches. The circle indicates the side of switch associated with the control mechanisms. The matrix of cross points, which gives full availability. No calls are lost unless all outgoing trunks are congested. The number of simultaneous connections that can be made is either m or n. The switch contains mn cross points. For m is equal to n, the total number of cross points are c is equal to n square. Thus, cost increases at the square of the size of the switch. However, efficiency decreases inversely with n. It is therefore uneconomic to use a single stage network for large number of inlets and outlets. Gradings. The number of outgoing trunks connected to incoming trunks is known as availability. Principle. For a root switch or a concentrator, it is not necessary for each incoming trunk to have access to every outgoing trunk. It is adequate if each incoming trunk has access to a sufficient number of trunks and each root to give the required grade of service. This is known as limited availability. The number of outgoing trunks to which an incoming trunk can obtain connection is called the availability. They correspond to the outlet capacity of the switches used. Figure shows 20 trunks on an outgoing route to which incoming trunks have access by means of switches, giving an availability of only 10. The outlets of the switches are multiplied together in two separate groups and 10 outgoing trunks are allocated to each group. If the total traffic offered by the incoming trunks is 8 headlongs, each group of outgoing trunks is offered 4 headlongs and will provide a grade of service better than 0.01. 16 trunks are interconnected to two groups of switches. I will have availability 10. The arrangement requires only one outgoing trunk than a full availability group having a similar grade of service. The technique described above of interconnecting the multiples of switches is called grading. An interconnection of trunks based on the principle is called as grading. The conventional diagram representation of a grading is as shown in the figure B. If the switches search sequentially for free outlets, the later choice outlets carry the least traffic. It is therefore desirable to connect the later choice trunks to both the group of selectors. In this arrangement, first 6 outlets are in separate full availability group. The last 4 outlets are common to both the groups and carries the traffic that overflows when the 6 outlets of either group are busy. Other form of grading, skipped grading. In this grading, in addition to communing adjacent groups, non-adjacent groups are also commonly connected. This avoids upper half and the lower half of the group to be separated. Traffic is eventually distributed in both the halves. Homogeneous grading. Progressive grading are intended to be used with the switches that hunt sequentially from a fixed home position. However, if the switches do not hunt from a single position, or they select outlets at random. There is no advantage in connecting some outlets to singles and others to partial or full commons. The grading should be designed to share each trunk between an equal number of groups as shown in the figure. This is known as homogeneous grading.